So set my thing as the active layer. This is the new tool. The toolbar is charge exclusion zones. So I can either select a specific ring, so that's the ring, or I can select a whole drive and then it'll apply to all the rings along that drive. In this case, I'll select the whole drive, and then Micromine will ask me to select a wireframe or polygon. So polygons need to be designed on the plane of the ring that you want to apply it to. In this case, I'm using a wireframe, which is typically more useful. I select my wireframe, and then Micromine asks me whether I want that wireframe to represent the area that I want to charge it inside of or outside of. I'll say inside of, and then I can specify a minimum stemming length. So I'll run that, and as you can see, it's just gone and charged the inside of that wireframe and left everything else uncharged. So that's essentially what it does in a nutshell. So most drill rigs have in their specification documents that are provided by manufacturers like a sort of area where it defines the coverage area of the rig. That essentially relates to the distance that rig can reach, in a sense. And that's what this first feature is about. So set it as the active layer, go to edit ring mode. So I'm going to come here in my ring design options, and these are all the new options that I was referring to. So the first one I'll show you is the boom extension limits. So I'm going to say that that the rig that I'm using, its boom can be extended to the left, right, up and down by 2 meters in each direction. And what Micromine will do when I define the rig or select my rig is ensure that as I'm moving the boom to the left or to the right, I'm not going beyond the coverage limits of the rig. So engineers can look at this drill rig specifications and find that coverage area and use this setting to essentially apply that coverage area while designing the drill holes. So it might not be obvious, but like I'm not able to move this more than 2 meters up, more than 2 meters to the left, or to the 2 meters to the right from its default position, which was in the center. So that's the first one. The next one, might turn that off for now. Height from floor. Actually, I'll show you these ones with a different example. Might be a little bit nicer to see that. Set it as the active layer. Edit ring. All right, so come back here. I can leave that on if I want. Height from floor, distance to sidewall. So these will ensure that the boom maintains a distance of 1.2 meters from the surface, no matter how rugged it is or how unlevel that area is. And these two settings will ensure that the boom does not get closer than 1 meter to the sidewall for safety reasons. So this particular ring plane doesn't really have a rugged surface. I'm going to go back one. Okay, here we go. This is one that looks like it's a bit funny. Okay, so let's say I place my rig here, and just note how as I move the boom to the left, Micromine will automatically move that boom up to maintain a distance of 1.2 meters from the surface. So you see how it's kind of going up by itself, and now it's going to slowly go down by itself. The annotations should also change, so let me just make sure I've set that up correctly. Maybe turn that off. That might be why it was acting a bit different than what I expected. Okay. So do you see how the boom's sort of going up? You can't see what I'm doing on my end, and now it's sort of going down. That's Micromine doing its own thing automatically. And now it's stopping me from going to the right too far because I'm within 1 meter of this right sidewall. So these are like, it's essentially just make people like, I'm applying these constraints so that I don't have to think about them while I'm in this environment. So applying the design constraints so that I don't have to worry about it now. So I can't go any closer than 1 meter to this right sidewall. Same with that, and this distance of 1.2 meters is satisfied at all times. Let me just show you this. It's another way to show you is probably using this one. So This will make it a bit more obvious. How that 1.2 meters is constantly maintained, no matter what the surface of the floor looks like. That's what that distance to floor essentially applies. And now you can see that 1 meter distance to the right sidewall. That's what these two guys actually do to the left and right sidewall. The pivot point setting essentially does what I just showed you. It reports the distance from the pivot point of the boom to the peripheries of the drive profile, and the bounding box option reports the distance from the rig to the peripheries of the drive, so the sidewalls and the floor. And these are all quite important for safety reasons, obviously, and for the engineer to have a good awareness of where he's placing the rig for the designing during the design process. What would happen in this case is if I wanted to be drilling for a ring here, but there was mining going on here, a bogger would essentially want to come here, turn left, take some material, come back and move out of this green tunnel. But if there's a drill rig drilling up into this ring, there's going to be some problems. So what we'd want to do is we'd want to get the drill rig to drill from this way. So typically you would be designing from this direction, but now you can mirror it as if you're designing from this direction. So I'll show you what I mean. Let's go to edit ring mode. Just hide that so it's not. So if I was drilling from this direction, but now I wanted to design from the other direction, I would just mirror the ring. And now I'm designing from the other direction. So it seems like a real basic feature, but you have to keep in mind that we need to be able to handle the drill hole angles and all the conventions and all that stuff, and that's what we've done, and that's where the work's gone into this particular feature. So it's pretty neat and pretty useful. I think the next one is see previous and next ring. So if I'm designing this for this particular ring and I want to see the previous ring, I just switch it on. If I want to see the next ring, I just switch it on, and you can see they're there. And if I'm going to now go through and add drill holes or a single drill hole, and I say to myself, okay, I know that in my previous ring there's a drill hole here, so what I might do is I might place that drill hole there, because quite often rings are blasted simultaneously, so there might be reasons for why I don't want the drill hole to be in that same area or that same position on the next ring. I might want it to be somewhere there in the middle of the last two rings. So that's where that sort of thing can come in quite handy. Here I've got a as planned ring design, so you can see that these are just quite nice, neat drives, because that's what I plan to do. Now this is my real as blasted, what happens really out in the field. So if I want to update this ring design to reflect the as blasted data, I will just set my ring design as the active layer, go to update or set drive wireframe, select the drive, tell it where the wireframe is. So Micromine will ask me to specify the as blasted drive wireframe, and then there's options to retain the existing drill holes and the drive boundary, or to get rid of them. So in this case I'm going to choose to retain them for reconciliation purposes and for redesign purposes. Click OK, and the difference now is that this guy is representing my real out in the field scenario, not what I plan to do. So now I've got as blasted data, and now I realize if I want to go and blast this next ring, for example, I'd need to do something like shorten these drill holes to the outline of the drive. Mining, ring design, export. I've already run it once, so what I might do is rerun it. So generate an interval file, run, yes, edit database. So now that I've created a drill hole database from that ring design database, I can open it in this interface, and now I've got a collar file to find the position of those ring collars. I've got an interval file associated with the charge. something like that. And then what I can do is I can I can essentially go to drill hole traces, solid traces, I should say, wherever that is, and use that to create solid traces.